Number 10. The History of Mercury. Before we really deep dive into the facts about the planet, let's talk about the beginnings of the planet in terms of its discovery from our perspective. Obviously, Mercury was made billions of years ago, but when exactly did we discover it? The earliest known recorded observation of Mercury are from the Mul.Apin tablets. These observations were most likely made by an Assyrian astronomer around the 14th century BC. The cuneiform name used to designate Mercury on the Mul.Apin tablets is translated as the jumping planet. Babylonian records of Mercury date back to the first millennium BC. The Babylonians called the planet Nabu, after the messenger to the gods in their mythology, which is ironic because Mercury is the name of the messenger god to the Roman pantheon. Many other civilizations found out about Mercury in their own ways, including the ancient Greeks, Roman, Chinese, and even the Maya. The first telescopic observations of Mercury were made by Galileo in the early 17th century. Although he observed phases when he looked at Venus, his telescope was not powerful enough to see the phases of Mercury. In 1631, Pierre Gassendi made the first telescopic observations of the transit of a planet across the Sun when he saw a transit of Mercury predicted by Johannes Kepler. In 1639, Giovanni Zuppi used a telescope to discover that the planet had orbital phases similar to Venus and the Moon. The observation demonstrated conclusively that Mercury orbited around the Sun. In the 1880s, Giovanni Schiaparelli mapped the planet more accurately and even perfectly detailed its orbital time around the Sun. As more time went on, more time was devoted to studying Mercury, including in the 1970s when NASA launched the first craft to Mercury via the Mariner 10. The Messenger and the Bepi Colombo would later follow in its footsteps. For the record, the Bepi Colombo is set to reach Mercury in 2025. Though there is still a lot we don't know about Mercury, we do know a lot based on probes and pictures and studies that have tided us over for the last few decades, which is why Mercury, like other planets, is well known enough to teach about. Number 9. Orbits and rotations. Mercury is a very interesting planet in a whole host of ways, not the least of which is because of the fact that it is indeed the closest planet to the Sun. Because of this, it has certain perks, as well as disadvantages. First and foremost, it's the closest planet to the Sun and the second hottest planet in the solar system after Venus. It's only 29 million miles from the Sun at its closest. Now yes, I'm sure this seems like a long distance, but when you're talking about the Sun, a sun that is 860,000 miles in diameter, that's not as far as you think. Because of this, it only takes about 88 days for Mercury to have a year-long rotation around the Sun, which is elliptical in nature for the record. And as for how long a day is, well, that's where the twist comes in. Because you see, a day is the amount of time it takes for the planet to rotate around its axis, right? Well, for Mercury, it has a very slow rotation. In fact, if you do the math, that would mean that the day count for about a year on Mercury is just over 1.5 days. That's some really weird planet calendar, but that's just how Mercury is. Number 8. How hot does it get there? The surface temperature of Mercury ranges from 100 to 700 Kelvin, minus 173 to 427 degrees Celsius, minus 280 to 800 degrees Fahrenheit, at most extreme places. It never rises above 180 Kelvin at the poles, due to the absence of an atmosphere and a steep temperature gradient between the equator and the poles. The sub-solar point reaches about 700 Kelvin during perihelion, 0 degrees west or 180 degrees west, but only 550 Kelvin at aphelion. On the dark side of the planet, temperatures average 110 Kelvin. The intensity of sunlight on Mercury's surface ranges between 4.59 and 10.61 times the solar constant. Although the daylight temperature at the surface of Mercury is generally extremely high, observations strongly suggest that ice, frozen water, exists on Mercury. The floors of deep craters at the poles are never exposed to direct sunlight, and temperatures there remain below 102 Kelvin, far lower than the global average. Water ice strongly reflects radar, and observations by the 70-meter Goldstone Solar System radar and the VLA in the early 1990s revealed that there are patches of high radar reflection near the poles. Although ice was not the only possible cause of these reflective regions, astronomers think it was the most likely. Regardless of that though, these extreme temperatures are why Mercury is such a different planet compared to the rest of the solar system. Number 7. The atmosphere. When thinking about a planet, one of the most considered things is the atmosphere, because through that we get a look at how the surface is affected and how life might be able to survive there. Mercury is too small and hot for its gravity to retain any significant atmosphere over long periods of time. It does have a tenuous surface-bound exosphere containing hydrogen, helium, oxygen, sodium, calcium, potassium, and others at a surface pressure of less than approximately 0.5 nPa, 0.005 picobars. This exosphere is not stable. Atoms are continuously lost and replenished from a variety of sources. Hydrogen atoms and helium atoms probably come from the solar wind, diffusing into Mercury's magnetosphere before later escaping back into space. Radioactive decay of elements within Mercury's crust is another source of helium, as well as sodium and potassium. Now, all of that being said, Mercury has a significant and apparently global magnetic field. According to measurements taken by Mariner 10, it is about 1.1% the strength of Earth's. The magnetic field strength at Mercury's equator is about 300 Nt. Like that of Earth, Mercury's magnetic field is dipolar. Unlike Earth's, Mercury's poles are nearly aligned with the planet's spin axis. Measurements from both the Mariner 10 and the Messenger space probes have indicated that the strength and shape of the magnetic field are stable. It is likely that this magnetic field is generated by a dynamo effect, in a manner similar to the magnetic field of Earth. This dynamo effect would result from the circulation of the planet's iron-rich liquid core. Particularly strong tidal effects caused by the planet's high orbital eccentricity would serve to keep the core in the liquid state necessary for this dynamo effect. Number 6. Life on Mercury? Given some of the things we just talked about, I'm sure it's a little weird for some of you that many think that there could have been life on Mercury at one point in time, and yet it's true. There may be scientific support based on studies reported in March of 2020 for considering that parts of the planet Mercury may have been habitable and perhaps that life forms, albeit likely primitive microorganisms, may have existed on the planet. The keywords you have to remember here are may have existed and parts of the planet Mercury, because while it is a planet that has a very rough surface and very fluctuating temperatures, it's also a planet that is surprising in how it has both ice and water vapor, and water is a key basis for life anywhere, including on Earth and on Mercury. Granted, no actual proof has been found that life was on Mercury, or when it was there and when it apparently died out. But if there is even a small chance that it was there at one point, you can bet that people are going to look into it, because if something can live on Mercury, even in the smallest of forms, it gives many hope for life on many other planets in the universe. Number 5. Mercury is big in pop culture. The smallest planet in our solar system has a big presence in our collective imagination, which is a bit interesting considering how much more popular the other planets are compared to Mercury. Scores of science fiction writers have been inspired by Mercury, including Isaac Asimov, C.S. Lewis, Ray Bradbury, Arthur C. Clarke, and H.P. Lovecraft. Television and film writers too have found the planet an ideal location for storytelling. In the animated television show Invader Zim, Mercury is turned into a prototype giant spaceship by the extinct Martians. And in the 2007 film Sunshine, the Icarus II spacecraft goes into orbit around Mercury to rendezvous with the Icarus I. In the comic strip Calvin and Hobbes, Calvin and his classmate Susie give a presentation about Mercury, in which Calvin's contribution is full of questionable information. The planet Mercury was named after a Roman god with winged feet, says Calvin. Mercury was the god of flowers and bouquets, which is why today he is a registered trademark of FTD florists. Why they named a planet after this guy, I can't imagine. Despite Calvin's analysis, Mercury has been used even more than that, which goes to show that when it comes to storytelling, just about any planet is a viable option for something. Number 4. Natural disasters. Here's something you may not know. Because of its proximity to the Sun and the lack of a true atmosphere, Mercury has no seasons, not a single one, which you would think would mean that Mercury doesn't have any natural disasters happen to it like they are on Earth. But that is only half true. Yes, in regards to things like rainstorms or tornadoes or hurricanes, Mercury will never have to worry about those at all. However, in regards to earthquakes, it is believed to have them. but not in the way you're thinking. Earth has earthquakes because of tectonic activity, but in regards to Mercury, it likely has earthquakes because the sun is quite literally shrinking the planet via its gravitational pull. What's more, because of the protective atmosphere and a weaker magnetosphere than what Earth has, Mercury is subjected to many different impacts from asteroids and meteors. Number 3. No moons or rings. It may seem rather obvious to indicate that Mercury has no moon or no rings. But what makes that such an important fact is that it's one of the few planets in our solar system that doesn't have a moon. Think about it. How many planets in our solar system don't have a moon? The answer is 2, Mercury and Venus. The reason they don't have a moon is honestly very simple. Because of how close they are to the sun, the gravitational pull of the sun is much greater than the planets. Thus, if any entity tried to make itself the moon of one of these planets, the sun's exertion would pull it away. This is the same reason they don't have rings, as any debris would be plucked away by the sun. Number 2. Gravity. Another major thing that is thought about when it comes to planets we might colonize is gravity. How much gravity a planet exerts will drastically affect its inhabitants and the planet itself. In the case of Mercury, the planet is one that has gravity 62% less than that of Earth, which means that if you weighed 100 pounds on Earth and somehow got to Mercury, your body weight, not including the spacesuit of course, would equal just 38 pounds. That means that you would be able to go and jump very high on the surface of the planet, but it also means that because of the reduced gravity, you would have to work very hard in order to ensure that your bones don't become brittle and weak due to the lesser forces exerted on it. Number 1. Could we live on Mercury? One of humanity's greatest things is the ability to think about possibilities. And when it comes to space, the possibility that everyone talks about is being able to live on other planets. Most agree that Mars is going to be the first planet we colonize. But what about Mercury? Could we live there? Technically speaking, we could, if we had the right amount of technology. It would be possible to shield ourselves from the sun and the massively fluctuating temperatures, which would be one of the biggest initial hurdles for colonizing there. However, the disadvantages of trying to live there far outweigh any pluses. True, we would have almost unlimited solar power, so that would be a plus. However, with no long-term atmosphere, as noted earlier, a planet that is only 2/5 the size of Earth, the tidally locked rotation, the supreme lack of gravity, soil that very likely won't support growth of crops and more, we'd have an even harder time colonizing Mercury than we would colonizing Mars. And colonizing Mars is going to be quite an endeavor. Could it be possible one day to colonize Mercury? Absolutely. With the right technology, anything is possible. But will we colonize Mercury? That's another story. Number 8. The history of Venus. Before we get into the facts and figures and the numbers behind the planet that is Venus, we probably should talk about how we discovered it. After all, astronomy has been going on for a very long time, and people have found planets like Venus before you would expect them to. In the old Babylonian period, the planet Venus was known as Ninciana, and later as Dilbat. The name Ninciana translates to Divine Lady, illumination of heaven, which refers to Venus as the brightest visible star. The ancient Greeks initially believed Venus to be two separate stars, Phosphorus, the morning star, and Hesperus, the evening star. Pliny the Elder credited the realization that they were a single object to Pythagoras in the 6th century BCE, while Diogenes Laertius argued that Parmenides was probably responsible for this rediscovery. Though they recognized Venus as a single object, the ancient Romans continued to designate the morning aspect of Venus as Lucifer, literally light bringer, and the evening aspect as Vesper, both of which are literal translations of their traditional Greek names. When the Italian physicist Galileo Galilei first observed the planet in the early 17th century, he found it showed phases like the moon, varying from crescent to gibbous to full and vice versa. When Venus is furthest from the sun in the sky, it shows a half-lit phase, and when it is closest to the sun in the sky, it shows as a crescent or full phase. This could be possible only if Venus orbited the sun, and this was among the first observations to clearly contradict the Ptolemaic geocentric model that the solar system was concentric and centered on Earth, which was one of many theories about how our world and our universe were at the center of it all, when in fact that couldn't be farther from the truth. The atmosphere of Venus was discovered in 1761 by Russian polymath Mikhail Lomonosov. Venus's atmosphere was observed in 1790 by German astronomer Johann Schroeder. Schroeder found when the planet was a thin crescent, the cusps extended through more than 180 degrees. He correctly surmised this was due to scattering of sunlight in a dense atmosphere. Later, American astronomer Chester Smith Lyman observed a complete ring around the dark side of the planet when it was at inferior conjunction, providing further evidence for an atmosphere. Believe it or not, it wasn't until the 1900s when more details and research was done on Venus, mainly because its shape, distance, and phases didn't give a lot of clues as to its various inner workings. Radar observations in the 1970s revealed details of the Venusian surface for the first time, thus giving scientists much more to work with. The first robotic space probe mission to Venus, and the first to any planet, began with the Soviet Venera program in 1961. The United States' exploration of Venus had its first success with the Mariner 2 mission on December 14, 1962, becoming the world's first successful interplanetary mission, passing 34,833 kilometers, 21,644 miles, above the surface of Venus and gathering data on the planet's atmosphere. Since then, numerous probes and satellites have been taken to Venus to study it in some capacity. There have even been talks of putting a rover on the planet in the same style that NASA has done with Mars, but that hasn't happened as of yet. Number 7. Orbits and rotations. Venus is known as our sister planet because in many ways it's like Earth. It's only a little bit smaller, has an atmosphere that is full of gases, and we do know that it has a distinctive surface like certain other planets in our solar system, but we'll get to that more later. Although it should be noted that despite the similarities to Earth, there are just as many differences that we'll be covering a lot in this list for various reasons. If you want to get really trippy on how different Earth and Venus are, you need to talk about how Venus handles its days and years. Because not unlike its own neighbor, Mercury, Venus has a very slow rotation, but to the extent that it's actually longer than a year. Yeah, that's right, a day is longer than a year on Venus. Its orbital period, or how long it takes to make a full rotation around the Sun, is about 225 Earth days, whereas a singular day on Venus is 243 days. That's weird. More than that though, it feels rather counterintuitive, because especially with how we live here on Earth, when it comes to years, they're the longest basic measurement of time. Many years make a decade, and so on. But when you think about how we count our lives, it's in years. So for a single day on Venus to be more than a year on Venus, that's really weird. And yet that's exactly what happens on the planet. So if we're going to live there, more on that in a bit as well, we're going to have to get used to some very funky things. Number 6. Seasons. When it comes to the seasons on Venus, it's definitely not like Earth is in any measure. In fact, it's kind of worse. As you likely know, the temperature on Venus is extremely hot. The average temperature is about 460 degrees Celsius due to the greenhouse effect that essentially turned the planet into an oven. That's a big reason why we don't dare try and colonize Venus, because anything we make would have to be able to withstand that heat, and that's not easy. A heat, by the way, that makes it the hottest planet in our solar system, even beating Mercury, which is closer to the Sun than Venus is. Plus, the tilt of the axis on the planet is so minimal that the temperature honestly doesn't change much on the surface of the planet. So seasons, as we know them, would be mostly hot to very hot, with little regard for things like cold or cool. When you add that up, it means that Venus is a place that nobody wants to live on, unless you're talking about in the atmosphere, where it's technically possible for us to live, but we'll get to that in a bit. Number 5. Greenhouse effect. Let's be honest here, when you think about Venus, you no doubt think about how it's a greenhouse planet, meaning that it has gases within its atmosphere that trap heat at such a rate that it makes it boiling hot. And that's very, very true. Studies have suggested that billions of years ago, Venus's atmosphere was much more like the one surrounding Earth, further proving it to be our sister planet, and that there may have been substantial quantities of liquid water on the surface. But after a period of 600 million to several billion years, a runaway greenhouse effect was caused by the evaporation of that original water, which created a critical level of greenhouse gases in its atmosphere. As a result, the planet is so hot that it can melt lead. And to many, Venus is the perfect example of what will happen to Earth if we're not careful with how we handle our own greenhouse gases. Number 4. Volcanic activity. When you think about Earth, it has many things that can shape the land, and one of them is volcanoes. They literally create islands when they erupt out of the ocean, and they can cause widespread destruction when they're erupting above the waters, like with Pompeii or Montana. Yet, did you know that Venus has a lot of volcanoes as well? What's more, it helped make the planet what it is today. Much of the Venusian surface appears to have been shaped by volcanic activity in some way, shape, or form. Venus has several times as many volcanoes as Earth, and it has 167 large volcanoes that are over 100 kilometers, 62 miles across. The only volcanic complex of this size on Earth is the big island of Hawaii, 154. This is not because Venus is more volcanically active than Earth, but because its crust is older. Earth's oceanic crust is continually recycled by subduction at the boundaries of tectonic plates, and has an average age of about 100 million years, whereas the Venusian surface is estimated to be 300 to 600 million years old. The volcanic activity is also believed to be a major reason that the atmosphere is what it is today, but more on that in a sec. Number 3. Pop culture. Named after the goddess of love and beauty, Venus has become nearly synonymous with women in popular culture. As referenced by the famous relationship guide Men Are From Mars, Women Are From Venus. Venus has also been used as the name for various beauty products and lyrics in songs like I'm Your Venus. As a solar system locale, Venus was a popular destination for early 20th century science fiction writers, before we knew about what lay beneath Venus's mysterious cloud cover. Writers could speculate about a more hospitable planet and its possible inhabitants. More recently, Venus has been a backdrop for video games such as Transhuman Space, Battlezone, and Destiny. And in the Disney animated film The Princess and the Frog, Ray the Firefly falls in love with Venus, the evening star, as he has mistaken it for another firefly. Various other sci-fi television shows and movies have made their own stakes on what Venus would be like as well, making it all the more curious to some that were not trying to colonize it and instead going to Mars, but there are many reasons for that. Number 2. Atmosphere. When it comes to planets, one of the first things that people talk about in regards to habitability is that of the atmosphere, which is where we get a major problem. Conditions on the Venusian surface differ radically from those on Earth because its dense atmosphere is 96.5 carbon dioxide, with most of the remaining 3.5 being nitrogen. If you're keeping track, that means that the planet has virtually no oxygen. To be clear, Earth's atmosphere doesn't have all oxygen either, but it's balanced with the elements of nitrogen, carbon dioxide, and others in order to let us breathe. But on Venus, that would be impossible for a whole host of reasons, not just that there's no oxygen in it for the most part. For example, remember those volcanoes we talked about earlier? They had a significant impact on the atmosphere because they added loads of sulfur into it. The atmosphere is acidic because of it. Sulfuric acid, if you're wanting the more scientific term. There is literally a cloud layer on Venus that is comprised of it. If that's still not enough for you, the mass of its atmosphere is 93 times that of Earth's, whereas the pressure at its surface is about 92 times that of Earth's. A pressure equivalent to that at a depth of nearly 1 kilometer, or 0.62 miles, under Earth's oceans, which means that any attempt to put a human on the surface of Venus would need a suit to be specially pressurized to combat the atmosphere. Number 1. Cloud City on Venus. I want you to picture Star Wars for a second, specifically Cloud City from The Empire Strikes Back. Remember how it was a city that was quite literally floating above the clouds? Well, there are some scientists who believe that we could do something like this on Venus and have a better life there than on the ground. How does that work? Simple. On the ground, the gases of Venus are so dense and troubling that having a colony there would be problematic. However, the higher you go into the atmosphere, the thinner the gases get. And scientists have theorized that at about 30 miles above the ground, there is a sweet spot that humans could use to survive long term, as well as a spot that is modest in temperature and pressure exerted. How do we get to be in a spot 30 miles above the surface? With a floating city or colony of sorts. I can hear the question in your mind, but wouldn't it be hard to keep the floating city afloat? Usually, yes, it would be, which is why, barring anti-gravity technology, we'll never have such a city on Earth. However, on Venus, the many gases in the atmosphere could be used by the blimps or however the colony is built to keep it afloat. It's actually been proposed before by scientists and is technically feasible with the technology we have right now. Plus, unlike a domed colony that we would have to have on Mars or the Moon, if something were to happen to the blimp, say a small tear in the hull, it wouldn't crash the whole thing or cause a series of catastrophic events that would kill everyone, as Venus's atmosphere is thick like Earth's, so we would have time to fix it before things got bad. And as noted, the pressure and temperature of the spot in the atmosphere the colony would be means that keeping it cool or warmed wouldn't take much energy or effort. Now, can we definitely say that we're going to be colonizing Venus soon? Of course not. That would be foolish. But whereas we were once very deterred from the notion, there is a chance and possibility now that this could happen, which is not unlike where we were with Mars at the beginning of the new millennium. And if we can get something working on Mars with its issues, something on Venus doesn't seem so far-fetched. Number 9. How we found Mars. If astronomy has taught us anything, it's that the earliest civilizations that were on Earth were incredibly advanced in not just looking at the stars above, but understanding what the various things in the night sky were and naming them to help them understand more. And that includes finding Mars and understanding what it was. Some of the early records of Mars's observation date back to the era of the ancient Egyptian astronomers in the 2nd millennium BCE. Chinese records about the motions of Mars appeared before the founding of the Zhou dynasty, 1045 BCE. Detailed observations of the position of Mars were made by Babylonian astronomers who developed arithmetic techniques to predict the future position of the planet. The ancient Greek philosophers and Hellenistic astronomers developed a geocentric model to explain the planet's motions. Measurements of Mars's angular diameter can be found in ancient Greek and Indian texts. In the 16th century, Nicholas Copernicus proposed a heliocentric model for the solar system in which the planets follow circular orbits around the Sun. This was revised by Johannes Kepler, yielding an elliptic orbit for Mars that more accurately fitted the observational data. So just in the finding of Mars, you had a handful of civilization not just finding Mars, but slowly learning more about it long before the modern age of astronomy ever came about, which just makes it all the more impressive that they were able to learn so much. In terms of the modern age, the first telescopic observation of Mars was by Galileo Galilei in 1610. Within a century, astronomers discovered distinct albedo features on the planet, including the dark patch Syrtis Major Planum and polar ice caps. They were able to determine the planet's rotation period and axial tilt. These observations were primarily made during the time intervals when the planet was located in the opposition to the Sun, at which points Mars made its closest approaches to the Earth. Better telescopes developed early in the 19th century allowed permanent Martian albedo features to be mapped in detail. The first crude map of Mars was published in 1840, followed by more refined maps from 1877 onward. When astronomers mistakenly thought they had detected the spectroscopic signature of water in the Martian atmosphere, the idea of life on Mars became popularized among the public. Percival Lowell believed he could see a network of artificial canals on Mars. These linear features later proved to be an optical illusion, and the atmosphere was found to be too thin to support an Earth-like environment, but we'll get to that later. Still, just in the discovery of Mars and its most basic elements camp across thousands of years of discovery and investigation, and to this day we're still learning a lot about Mars. Number 8. Orbits and rotations. If you somehow haven't heard, the world is trying to get humanity onto Mars so that colonies can start to be formed. But to truly help people adapt to that notion, certain variables need to be understood, like how the orbits of Mars works, and the seasons that the planet may or may not have. First and foremost, a year on Mars is almost double that on Earth. Earth is 365 days and Mars is 687 days. This is due to the fact that Mars is much farther away from the Sun than Earth is, and thus has farther to go. Now on the flip side though, the rotation of Mars is just barely slower than Earth's. So instead of a 24-hour day, we actually have a 25-hour day more or less. The actual number is 24.62. That's not too bad of a twist, right? As for the seasons, that's a bit trickier, because on one hand it does have spring, summer, fall, and winter in the overarching sense, but they all pretty much last over 150 days, roughly, versus the 90-day average of Earth. Spring, if you can call it that, even goes as long as 7 months. Winter is the shortest with about 120 days. Plus, since Mars's orbit is elliptical and not circular, it has 2 additional seasons called aphelion and perihelion, meaning that it's got a new season when it's closest to the Sun, and 1 season when it's farthest away from the Sun. If humanity is going to last on Mars, we're going to need to adapt to the seasonal changes, especially in regards to how the temperatures on the planet can swing wildly from day to night, as well as season to season on the surface. It's not an impossible thing to overcome, but it's something we'd have to be ready for. Number 7. Water on Mars. Without a doubt, one of the most important discoveries on Mars is that there is indeed water on it. As noted in its history from the Earth side of things, there was a long-time belief that Mars always had water, but this was later revealed to be an illusion. However, as time went on, there were signs that there was some kind of water on Mars in its past, and possibly in its present. The only problem was that it couldn't be liquid water due to the thin atmosphere above the planet, as well as the total lack of magnetosphere. However, that doesn't mean they failed to find it. In July of 2018, scientists reported the discovery of a subglacial lake on Mars, the first known stable body of water on the planet. It sits 1.5 kilometers or 0.9 miles below the surface at the base of the southern polar ice cap and is about 20 kilometers or 12 miles wide. The lake was discovered using the Mars's radar on board the Mars Express orbiter, and the profiles were collected between May of 2012 and December of 2015. The lake is centered at 193 degrees east by 81 degrees south, a flat area that does not exhibit any peculiar topographic characteristics. It is mostly surrounded by higher ground, except on its eastern side where there is a depression. Add to that the various polar caps and other ice entities on the planet, and suddenly Mars isn't just a place to fantasize living on. We can do it because we know that there is water there that we can use. Number 6. Atmosphere. As noted, Mars has a very complicated history in regards to its atmosphere. Mars lost its magnetosphere 4 billion years ago, possibly because of numerous asteroid strikes, so the solar wind interacts directly with the Martian ionosphere, lowering the atmospheric density by stripping away atoms from the outer layer. Compared to Earth, the atmosphere of Mars is quite rarefied. The atmosphere of Mars consists of about 96% carbon dioxide, 1.93% argon, and 1.89% nitrogen, along with traces of oxygen and water. The atmosphere is quite dusty, containing particulates about 1.5 micrometer in diameter, which give the Martian sky a tawny color when seen from the surface. It may take on a pink hue due to iron oxide particles suspended in it. In short, this means that we can't just openly breathe the air on Mars, and going to the planet without a pressurized suit would be dangerous in all the ways that matter. As such, any colony that we try and build there will be one that has to be pressurized and have oxygen made and recycled so that we can breathe. Number 5. Soil. You might think it odd to wonder about the soil conditions on Mars, but in fact, they're some of the most important things that NASA scientists are trying to learn about. The Phoenix lander was sent to observe said soil, returned data showing Martian soil to be slightly alkaline and containing elements such as magnesium, sodium, potassium, and chlorine. These nutrients are found in soils on Earth, and they are necessary for growth of plants. Experiments performed by the lander show that the Martian soil has a basic pH of 7.7 and contains 0.6% of the salt perchlorate. This is a very high concentration and makes the Martian soil toxic, which is very bad considering we're wanting to try and use that soil to grow crops for the future colonies. The other problem with the soil that scientists have noticed is that it's incredibly clingy as well as sharp. This means that astronaut suits will have to be very strong to not get torn up by the dust, and advanced cleaning techniques, or creative ways to get in and out of the suits, will be needed to ensure that the dust doesn't find a way inside the colony itself, as this dust would not just damage the ships and colonies, but if breathed in, could be very detrimental to the colonists themselves. As if that wasn't enough, there is speculation that there are billions of dollars worth of materials on Mars just waiting to be mined. Places like NASA and SpaceX are considering how to mine for those materials to help fund future missions to the Red Planet. Number 4. Pop culture. To say that Mars is part of pop culture on the planet Earth is an understatement in all the ways that matter. From basic references to being an integral part of shows and movies, Mars has been around. In the late 1800s, when people first observed the canal-like features on Mars' surface, many speculated that an intelligent alien species resided there. This led to numerous stories about Martians, some of whom invade Earth, like in the 1938 radio drama The War of the Worlds. According to an enduring urban legend, many listeners believed the story to be real news coverage of an invasion, causing widespread panic. Which is ironic because if they listened to the end of the program, the narrator clearly stated that it was just a story. Countless stories since have taken place on Mars or explored the possibilities of its Martian inhabitants. Movies like Total Recall, 1990 and 2012, take us to a terraformed Mars and a struggling colony running out of air. Martian colony and Earth have a prickly relationship in the Expanse television series and novels. And in the 2014 novel and its 2015 movie adaptation, The Martian, botanist Mark Watney is stranded alone on the planet and struggles to survive until a rescue mission can retrieve him. And keeping in line with the mythology of the planet, the name Mars has been awarded to various characters in cartoons and anime, and even video games for their strength, size, and godlike appearances. Number 3. Moons. The moons get their names from the horses that pulled the chariot of the Greek god of war, Ares. In ancient Greek, Phobos means light and Deimos means fear. Phobos, the innermost and larger moon, is heavily cratered with deep grooves on its surface. It is slowly moving towards Mars and will crash into the planet or break apart in about 50 million years. Deimos is about half as big as Phobos and orbits 2.5 times farther away from Mars. Oddly shaped Deimos is covered in loose dirt that often fills the craters on its surface, making it appear smoother than Phobos. The moons of Mars are another that are being studied very carefully. For while a full-blown colony may not be in the cards for these moons, a way station of sorts is possible, and certain theories about the future of space travel have pondered how these moons could help launch us into the back half of the solar system. Number 2. Terraforming. Given all the hardships that are on Mars, from the atmosphere to the soil to the seasons and more, it might seem that this is too big a risk to try and colonize it. And to an extent, you would be right. Even if everything goes right, it'll take years to set up a true colony on Mars. And to be honest, it probably wouldn't be the easiest living place for a long time. However, there are ideas and notions to try and warp Mars into a more sustainable habitat for us. Simply put, people are wondering whether we can terraform Mars into something more like Earth. Now obviously, this would be a grand endeavor, but it's not as much a sci-fi theory as you might expect. Some have put forth ideas of not terraforming the whole planet, but rather a section of the planet. Think of it like a country-sized safe zone where we could build the colonies in peace. Again, it's not that far-fetched. There are technologies out there that theoretically make this happen, including sending nanobots to the skies to help make an atmosphere of our own. Other theories could rework the ground itself into trying to make it something we can grow plants into. Right now it's all theory, but theory is the first step towards making something work. Number 1. Life on Mars. There are some in the world today who truly believe that Mars is where humanity will take its next grand step. If that is the case, it'll be the most significant thing humanity has done since landing on the moon. Plans from groups like NASA, SpaceX, and the ESA and more have their various plans to get to Mars and beyond. But will they happen? It's hard to say. And of course, even if they do land on the surface of Mars, will a colony really be that easy to set up? These are the questions we will have until we start taking steps towards human expansion in the universe.